Hello students, in this video I am going to discuss the next topic of the chapter coordinate geometry, that is section formula. At first I will discuss about the section formula and then I will derive the formula. That means I will derive the expression of the section formula. Okay. Now what is actually this section formula? Right? Suppose AB is a line segment where C is a point lies in the length, anywhere in the length of AB, and this point C divides the line segment AB internally into two parts, that are those are AC and CB. Okay, this length is AC and this much length is CB. Now suppose I am taking the ratio of the lengths of line segment AC and line segment CB is ratio of the lengths of line segment AC and line segment CB as M is to N. So this much will be M and this much will be N, right? So by this point C, the line segment AB is divided into two line segments AC and CB. Now let the coordinate of the points, point A is x1 comma y1, and the coordinate of the point B, that is x2 comma y2. I have to calculate the coordinate of the point C. Let the point coordinate of the point C is x comma y. Now by section formula we can find out the coordinate of the point C, where the line segment AB is divided into two parts AC and CB internally, where the ratio of their lengths are M and N. M is to N. Okay. After derivation, we will get x as mx2 plus nx1 by m plus n. That is actually the abscissa of the point C, and the ordinate of the point C will be, that is y. The expression for y will be my2 plus ny1 by m plus n. So in this way we can get the coordinate of the point C is mx2 plus nx1 by m plus n, comma my2 plus ny1 by m plus n. That is actually x comma y. So whenever you will be solving any problems regarding the section formula, you will be having two endpoints of the line segment, that is A x1 comma y1, B, that is x2 comma y2. These are the two endpoints of the line segment. M is to N is the ratio of the line segment length of AC and CB, and the coordinate of the point C, where the line segment AB is divided internally in the ratio m is to n, that will be x comma y. You have these four things. Any three among this will be given and you will have to calculate the other one. Suppose in any problem you are given with these two coordinates and this ratio, then by applying this formula you will have to calculate the coordinate of the point C. Now let's see how to derive this expression, and for that you need to understand the concept of similarity of two triangles. In these two triangles, triangle ABC and triangle PQR, angle A and angle P are the corresponding angles, angle B and angle Q are the corresponding angles, and angle C and angle R are the corresponding angles. If I have to show these two triangles are similar, then these three pairs of corresponding angles of these two triangles must be equal. That means angle A must be equals to angle P, angle B must be equals to angle Q, and angle C must be equals to angle R. If I can show this thing, then I can say that these two triangles are similar to each other. This is the sign of similarity. Now, if these two triangles are similar, then the ratio of the lengths of their corresponding sides must be equal. That means in the triangle ABC, I have taken the length of the side AB, and in triangle PQR, PQ is the corresponding side of the side AB in triangle ABC. So AB by PQ, in the similar way, BC by QR equals to AC by PR. BC and QR are the corresponding sides of these two triangles, and AC and PR are also the corresponding sides of these two triangles. So the ratio of the lengths of the corresponding sides of these two triangles must be equal if these two triangles are similar to each other. Okay. Now see, if I have angle A equals to angle P and angle B equals to angle Q, and if I add these two equations, then I can get angle A plus angle B equals to angle P plus angle Q, right? Now 180 degree minus angle A plus angle B equals to 180 degree minus angle P plus angle Q, right? Now in triangle ABC, what is 180 degree minus angle A plus angle B? That is angle C, right? Because we know that angle A plus angle B plus angle C is 180 degree. So Here I can write angle C, and here for triangle PQR, in the same way I can write angle R. That means if I have only two corresponding angles of these two triangles are equal, then the third pair of corresponding angles will be automatically equal. That means I need at least two corresponding angles equal. That will be the angle-angle similarity. Of triangles. I am going to use this similarity criteria for my derivation of section formula. Now see, here I have taken two axes, x-axis and y-axis, and the point O as the origin here. Now let's take a line segment AB with the ending points A and B, and the coordinate of the point A is x1, y1, and coordinate of the point B is x2, y2. Okay. Now C is a point lies on the line segment AB, which divides the line segment AB into two line segments AC and CB. Okay. In the ratio M is to N. That means the ratio of the lengths of line segment AC and CB is M is to N. So this much of length will be M unit and this much will be N, right? Now let's draw two perpendiculars from the point A, C and B to the x-axis. Okay, let's name it M, N and Q, and draw a parallel line from the point A on the line segment CN and from point C on the line segment BQ. Name this as U and V. Okay. I have drawn these line segments AU and CV parallel with the x-axis. So this angle and this angle are the corresponding angles, so they will be equal, and the line segment CN and the line segment BQ are perpendiculars on the x-axis. So this is 90 degree, it is right angle, this is also 90 degree right angle. So we can say that triangle AUC and triangle CVB are similar according to angle-angle criteria, right? Now, since these two triangles AUC and CVB are similar, we can say that the ratio of their corresponding sides will be equal. That means AU by CV equals to CU by BV equals to AC by CB. Now see, we know that the point C divides the line segment AB internally into two different line segments, AC and CB, in the ratio M is to N. That means AC by CB is equals to M by N. So we can write here M by N, right? So we can also write AU by CV equals to M by N and CU by BV equals to M by N. We can write these equations from this expression, right? Now we will derive the section formula from these two expressions, okay? Here we will calculate the length of AU, length of CV, then we will calculate the length of CU and length of CV, then we will put those values here, okay? See, since the coordinate of the point A is x1, y1, this much length will be x1 and this much length will be y1, right? This length will be x and this much of length will be y, because the coordinate of the point C is xy, okay? Now the total length here will be x2 and the total length here will be y2. Now try to find out the length of AU. This total length is x unit and this much of is x1 unit. So the length of line segment MN, which is actually equals to length of line segment AU. What is the value of the length of line segment MN? That is x minus x1, right? So in the place of AU, I can write x minus x1. Then in the place of CV, what is the length of CV? This entire length is x2 and this much length is x. So the length of line segment NQ, which is actually equals to the line segment length of line segment CV, that is x2 minus x, okay? This is equals to M by N. Right? If we calculate this expression here, we can get x equals to mx2 plus nx1 by m plus n. Do this calculation by yourself. Similarly, if we put here the value of CU, that is this total length is y and this much length is actually equals to the line segment, length of line segment AM. This is y1. This is also y1. So y minus y1, that is equals to CU, length of CU. So y minus y1 by the length of line segment BV, that is y2 minus y. Okay, from here we can get y equals to my2 plus ny1 by m plus n. Okay, so the coordinate of the point C, where actually the line segment AB was divided into two parts in the ratio m:n, coordinate of that point C is x comma y, where x is the abscissa and the value of x is this, and y is the ordinate where the value of y is this. Okay, this is known as the section formula. And one special case is there. Suppose a line segment AB is divided at a point C internally, and the ratio of line segment AC and line segment BC, the length of them are in ratio 1:1. That means C is the middle point of the line segment AB. C has divided the line segment AB equally in two parts. Okay, so the formula for the coordinate of the point C will be, here I am writing the coordinates of A, that is x1 comma y1, and B x2 comma y2. Okay, then we just have to put the value of m and n as 1. Since here the ratio was m:n, here the ratio is 1:1 in place of m:n. So put the value of m equals to 1 and n equals to 1 here in these two formulas. Then we will get x as x2 plus x1 by 2 and y as y2 plus y1 by 2. Okay, this is the coordinate of the middle point of a line segment.